Hello, welcome back to my channel. Today I'll be solving a very simple but tricky math challenge which at first sight seems unsolvable. So someone brought that challenge to see if I can solve it or not. And here is what the equation looks like. It's a normal algebraic equation 2 to the power x plus x equals 20, and you have to find the value of x. So I will urge you to pause the video and give it a try before you continue watching the video. If not, you won't understand why I tagged that particular problem very tricky and very technical. Just pause the video and try to solve it. Alright, so let's jump into the details of how to solve it. Okay, so I'll be using this page to solve the problem. 2 to the power x plus x equals 20. If you want to try using logarithm here, you will complicate everything. And if you are trying to apply your knowledge of indices here, it will really take your time. And I don't know if it will work either, because I've tried it and I was just going back and forth in the whole process. So now, the method and the idea that would work here is what we call Lambert W function. Lambert W function is a special function denoted by the letter W. Okay, denoted by the letter W. Now, the Lambert W function, this definition, I've not started solving it. So the Lambert W function of anything, say A, right? Exponential. The Lambert W function of A is what is equal to A, and this is same as the Lambert W function of A exponential A is equal to this and is equal to this. So now we are going to be breaking down this equation to the point that we want the left hand side to be of the form a term that's something like, let's say, x plus 4 exponential x plus 4. So we want that term that is here multiplying e to the power of that same term. So that's what we are going to be trying to rearrange this equation to be. Okay, and you may need to follow me carefully, if not you will get confused in the process. I may need to add that at the first attempt I wasn't able to solve it. So in case you tried it and you were not able to solve it, you are not alone. Okay, so now this, after we make the left hand side and the right hand side be of this form, we can apply this Lambert W function. And Lambert W function of anything multiplied by e to the power of that will give you just that A. We are going to start solving this equation. We have 2 to the power x plus x equals 20, right? The first step to take that will bring us one step closer to making the equation looks like this is to move this x to this side. I tried a lot of rearrangements before I found out that this is one that works. If you want to get the answer correctly at first attempt, you have to be very good. Otherwise, so you have to our x. Now, what would you do to take x to this side? Subtract x from both sides. So you have 2 to the power x. When you subtract x from this side, you have x minus x. It will be 0. So leave it there. Now here 20. Subtracting x will be minus x. The next thing is divide both sides by 2 to the power x. Just follow me carefully. Divide both sides by 2 to the power x, right? Now 2 to the power x divided by 2 to the power x. 2 to the power 2 to the power x will give us 1, right? So the left hand side of the equation becomes 1. Now 1 equals 20 minus x. Now this is where you use your knowledge of indices. See, there is this rule in indices that if you have something, let's say x to the power w all over y to the power p, this thing can be reformed to be equal to x to the power w times 1 over y to the power p, right? because when you multiply it, you still get back this. And now this can be written as x to the power w times y to the power minus what? Minus p, the inverse rule. This thing here is equivalent to this thing here. Why this? Nothing's changed. You will now have it to now be equal to x to the power w into bracket y to the power minus p, right? So this holds. Now this is knowledge you are going to be applying here. We have this whole thing divided by this. So this is the same thing as saying 20 minus x. You have 20 minus x, right, over 2 to the power x. This is the same thing as saying 20 minus x close in bracket multiplying 1 over 2 to the power x, right? Multiplying it, right? Now this is the same thing as 20 minus x multiplying 2 to the power of negative x from this same illustration I give. That's the same thing you do. Now this is what we'll now bring back and put it here. We have 20 minus x 2 to the power minus x, right? At this point, we are going to do something else that also brings us one step closer to making our equation look of this form. What we are going to do is multiply both sides by 2 to the power 20. You will see why we are multiplying both sides by 2 to the power 20 in a moment. Just follow carefully. Now you are multiplying both sides by 2 to the power 20. This left hand side multiply by 2 to the power 20 will give us what? 2 to the power 20 times 1, the same thing as 2 to the power 20, right? This right hand side, you have to understand something here. We have the whole of this. This is what we have on the right hand side here. So multiply it by 2 to the power 20. You will now see that there is a law of indices that can be applied to these two terms here. You know, we have that if you have two numbers in index form multiplying each other and the numbers are the same but their powers are different, you just pick one of the base, so everything will now be equal to 20 minus x. So in this case, you pick 2. 2 is the basis and they are the same. So you pick 2 and then sum up the power. Minus x plus 20 is the same thing as 20 minus x. Understand? Yes. So you are now going to have 2 to the power minus x plus 20, which is equal to 20 minus x 2 to the power 20 minus x. That is what we are going to put on the right hand side of the equation. 20 minus x 2 to the power 20 minus x. Now I don't know if you are starting to see the pattern here. You know, we are trying to make it be such that a term is multiplying e to the power of that same term, right? Now 20 minus x is the same thing as the power 20 minus x here, so we could just quickly go and apply Lambert W function to this right hand side. But wait, this here is 2 and it's not e. If it was e, we can apply the Lambert W function. So we have to make here e using a property of exponents. The property is this. Let me put it in a box. This is the property. A term, let's say y, for instance, it can be written as e to the power of ln of that same term, because e and ln, e which is the same thing as exponential, and ln are inverse of each other, so they will cancel out, left with y. So now we are not going to use this property. These two here will be written as what? E to the power of what? Ln 2. I don't know if you understand. If you don't understand all of this, you may revisit your secondary school maths textbook after watching this video. Yes. So now I'm not going to write this as that form. So we have the left hand side remains the same. So you have 2 to the power 20 equals to 20 minus x. E, now this 2, we are changing it to this form. It will be e to the power of ln 2, right? And then put in bracket everything that is here. You have 20 minus x, right? Now you could see this side here now is now e, but this up and this down are no more the same, so we can't apply Lambert W function. So we still need to do something else. Now what makes here and here different is this ln 2. So if we are to multiply both sides by ln 2, you will see that this side multiplied by ln 2 will be what? 20 ln 2, right? Equals to, now this side multiplied by ln 2 will be what? Ln 2 times all of this, which will be ln 2 into bracket 20 minus x, right? Ln 2 into bracket 20 minus x e to the power of ln 2 into bracket 20 minus x. Now observe that this here now and this are the same, so we could apply the Lambert W function. So Lambert W function says the Lambert W function of ln 2 into bracket 20 minus x exponential ln 2 into bracket 20 minus x is equal to ln 2 into bracket 20 minus x, right? So let's just make it clear here. Apply Lambert W function to both sides. 20 ln 2 equals to Lambert W function of what? Ln 2 into bracket 20 minus x exponential ln 2 into bracket 20 minus x, right? So close the bracket. You say it's equal to what? Let's just write everything in full. Lambert W function of 20 ln 2 is equal to ln 2 into bracket 20 minus x, right? Hope you understand how this turned into this simple one because of this property of Lambert W function. It's called the product log. The product log, okay. It's called Lambert W function or product log. So this is the rule we are using to solve this particular problem. Now, from here, we are after getting this side to be very simplified, we are now going to focus on this other side to try to make it look of this form also. To make it look of this form, what are we going to do? The first step is to rewrite this. Okay, I don't know if you spotted a mistake I made in this process. I had to pause this video to recheck. Here on this left hand side, we have 2 to the power 20. How does that immediately becomes 20? I don't know if you get. This ln 2 here was what we got after multiplying both sides of the equation by ln 2. So here is supposed to be 2 to the power 20 ln 2. I don't know if you get. That's the correction I have to do before I would be able to continue this solving process. So that's that. Now you have this. So this 0 is not there, please. So you have 2 to power what? 20, 2 to power 20. Okay, so here one thing we will do that will bring us closer to making this left hand side look of this form is to write this 2 to power 20. See this 2 to power 20 here in the using the property of indices. 2 to power 20 is the same thing as 2 to power what? 4 times 2 to power 16, because this is the rule I talked about earlier. Where is it? This one here, the rule I talked about when I told you that this is equivalent to this, right? 2 to power minus x times 2 to power 20 is equivalent to 2 to power minus x plus 20. So the rule I talked about at this point is the same rule I'll be using here. 2 to power 4 times 2 to power 16 is the same thing as 2 to power 4 plus 16, which will give you 2 to power 20. So here is still mathematically correct. So now have this multiplying ln 2 equals to ln 2 into bracket 20 minus x, right? Hope you are following though. This one here can be written in exponential form again using this property here. Okay, this will now be Lambert W function of 2 to the power 4 is 16, right? So it will be 16 times. Now we are writing this in this form. So it will be e to the power of ln what? Ln 2 to the power 16. Hope this is clear, right? Now this whole thing here is equivalent to this one here. Now multiply it by ln 2, which was already there. This ln 2. So this is equal to ln 2 into bracket 20 minus x, right? There's still another property of exponent you need to apply here. This is the property here that e to the power of ln a to the power of another power b is equals to e to the power of that power b multiplying ln a, just like this, where a and b are representing any number or any term or any expression. So that's what we are going to be using here. We have e to the power of ln 2 to the power 16. So this will be the same thing as e to the power of 16 ln 2, right? Now, this ln 2 multiplying 16 will also give us 16 ln 2. So I don't know if you can clearly conclude what our result after taking the Lambert W function will be here. I hope you see. This is same as this, which is same as this product log formula. Now we can now take Lambert W function. Let's write the right hand side first. Ln 2 into bracket 20 minus x. Now taking the Lambert W function will result in 16 ln 2 equals ln 2 into bracket 20 minus x, right? Now divide both side by ln 2. Divide both side by ln 2. So ln 2 into ln 2 is 1, which will cancel out. Ln 2 into ln 2 is 1, which will cancel out. So what is left is 16 equals 20 minus x. Now it's obvious what the value of x is from here, right? So rearranging the equation, to move 20 to this side. This implies that minus x equals what? When 20 comes to this side, it becomes negative, right? So it will be 16 minus 20, isn't it? 16 minus 20 give us minus 4, right? Minus 4 equals to minus x. Divide both side by minus 1. Divide both side by minus 1. Therefore, 4 equals to x, which implies that x equals to 4. And that brings us to the final but stop for this whole process. Please make sure to subscribe for videos related to academics.